Sir has joined in.
So can we start? Good morning, sir.
Yeah, just say okay and I will start.
So principal sir has joined.
Okay.
Good morning.
Good morning, sir.
Good morning.
Good morning, sir. So can we start now? Good morning, everyone. I welcome you all on the 4th day of EFDP on research methodology, tools and techniques, organized by IQAC of ATMA SANATAN DHARMA College in association with TLC Ramanujan College, University of Delhi. On behalf of ARST College, I welcome our guest speaker, Dr. Ajay Kumar Chauhan, founder of ResearchSiksha.com, consultant, data science and analysis, and trainer, big data analytics for today's session. We are really grateful, sir, that you took out time for us. Now I would like to invite our principal, sir, Dr. Gyantosh Kumar Jha, to welcome our guest and say a few words of encouragement.
Thank you, Anupriya. Good morning to all. On behalf of the college, it's my pleasure and honor to welcome Dr. Ajay Kumar Chauhan in this faculty development program. I welcome all the participants also in this session. And in fact, we are on 4th day today. So it's my great pleasure that Dr. Chauhan has given his valuable time to deliver his 2 lectures in this faculty development program. Thank you, Dr. Chauhan.
Thank you, sir.
Again, I welcome Dr. Chauhan and all the participants. My best wishes to all. Thank you so much.
Okay, thank you, sir. Thank you. So, I hope I can start now.
So I need an introduction of yours just for a while. Thank you,
Okay.
sir. Dr. Ajay Kumar Chauhan is the founder of consulting firm Research Siksha. He is an expert of quantitative methods. He is a visiting faculty with MDI, IMT, IIFT, NIT, etc. Earlier, he was associated with IMT Ghaziabad as a full-time faculty for 28 years. He is MSc in Mathematics, MBA Finance, and also done his PhD in Finance. He has 20 years of experience in academics and industry. He has, to his credit, 25 international research publications and 3 books. He is a well-known trainer of data science and analysis and has conducted more than 500 national and international training workshops on topics such as financial econometrics, time series analysis, structure equation modeling, and business research methods in reputed institutions of India, such as Coca-Cola, IMT Ghaziabad, UGC academic staff colleges, Ministry of Communications, and many more. He has also taught in Bulgaria and done an advanced course in econometrics from Switzerland. I welcome you again, sir, and invite you to start your presentation on today's topic, correlation, causation, and bivariate regression. Thank you, sir.
Okay, so thank you, Anupriya. Now I'm going to start. And so I formally start. So I think there is no need to ask that whether I am audible and can you see the slides? I assume that, yeah, it is visible. So basically, there are 3 things. One is known as correlation. And second is causation. And the third concept is called regression. So there are 3 concepts which are behind the regression model. And without understanding this concept, there is no point in going further. So I start my workshop with few common sense questions. With if you apply, you can answer it very easily. Okay, so what happened? One researcher, he took the data of 2 variables. The first variable is y, and the second variable is x. Now, what is y and what is x? I'm telling you. The y is the crime in Africa, and the x variable is a salary of university professors. University of professors. So these are the two variables that we have in the data set. And the data is from 1950 up to 2020, let's say 18. So we are having the data set like this. Now, I'm going to ask some query to you and you have to give me the answer with your common sense. The first is, what kind of a relationship you are expecting between the X variable and the Y variable. So you have the chat box with you and just write positive or negative. So what kind of variable, what kind of relationship you are expecting between the Y variable and the X variable? So you are saying negative. No relationship. Negative. No. Yeah. But actually, I requested you to apply your common sense. Why I say so? Have you seen in your life that salary decreases with time? आपने अपनी जिंदगी में कभी ऐसा देखा है कि सैलरी कभी टाइम के अकॉर्डिंगली कम हुई हो? नहीं देखा ना? So salary always increases with time. And now come to second variable, crime in Africa. अब अफ्रीका में क्राइम टाइम के अकॉर्डिंग कम हुआ है या ज्यादा हुआ है? So the crime in Africa increases from 950 to 218 or it decreases? Increases. So there is a so I again remind you, whatever I am asking is not from, I am not asking your general knowledge, I am asking from your common sense, right? Common sense. So no GK is required in this, only simple common sense is required in this. So now let me if I plot the two variables, the salary also increases with time like this, and crime also increases with time like this. So this is the salary of a university professor and this is the crime in Africa. Now tell me, can you see the negative relationship between the two, or there is a positive relationship between the two, or there is a no relationship between two? So use your common sense and tell me what kind of relationship you are expecting. So now I'm getting the right answer, positive. So there is positive relationship between the two because both are increasing with time. Both variables are increasing with time. So there exists positive relationship between the two. Okay. So my first conclusion is that both X and Y have positive relationship. Now my second question is that can you say the crime in Africa increases because the salary of university professor increases? Okay, so now I am getting the right answer. So we are having the X and Y. Can we say like this? So here we are not having any logical explanation. We are not having any logical explanation that crime in Africa increases because salary of university professor decreases. So this relationship we cannot explain logically. This relationship we cannot explain logically. Okay? So logic is not there. Logic is not there. And so now this concept is called correlation. And this concept is called causation. Causation, right? So when we cannot have the logical explanation between the relationship between X and Y, it means causation is not there. Correlation is there. Significant correlation is there, but causation is not there. So this is the basic difference between correlation and causation, right? And if causation is not there, you cannot go to the regression part. So the concept is like this. First, we observe the correlation between the variables. Then we try to find out the causation or the logical explanation between the variables. And if we have logical explanation, then we can go to regression. Then we can go to regression. So this is the flow chart between correlation, causation, and regression. Correlation, causation, and regression, right? So this is the concept. Now I'm taking one more example. Okay. Now there are two variables, GDP and interest rate. So there are two variables, GDP and interest rate, right? Now tell me with your common sense, or now here some general knowledge is also required. That interest rate is what is the possible relationship between the interest rate and GDP? Interest rate और GDP में क्या संबंध होता होगा? तो okay. So most of the people are saying that there exists positive relationship between the two. Okay. मुझे नहीं पता कि आपने इकोनॉमिक कहां से पढ़ी है. I don't know. But there is negative relationship between the two. Actually, when interest rate is low, GDP is high. Why? Because when interest rate is low, consumer take more loans, and more loans means more usage of money, and money supply will increase, and money supply, because of money supply, GDP will increase. तो जो interest rate का impact basically दोनों के बीच में relationship negative होता है. There is a negative relationship between the interest rate and GDP, and if somebody is from economics, he can explain the logic also. Okay. तो मेरे ख्याल से आपको ये यहाँ तक तो समझ में आ गया होगा कि इंटरेस्ट रेट जो है अगर वो ज्यादा हो तो लोग लोन कम लेते हैं, जीडीपी डिक्रीज हो जाती है. अगर इंटरेस्ट रेट इकोनॉमी में कम हो, लोग लोन ज्यादा लेंगे, कंपनी ज्यादा लोन लेगी और उससे प्रोडक्टिविटी बढ़ेगी, जीडीपी बढ़ेगा. तो मैंने तो इकोनॉमिक्स में यही समझा है. खैर, मतलब इसमें ऐसी बहुत ज्यादा हार्डकोर इकोनॉमिक्स नहीं है, कॉमन सेंस वाली इकोनॉमिक्स है. तो चलिए, my second question, right? My second question is that which is dependent and which is independent? Can you guess which variable is dependent on other? Which variable depends on other? GDP depends upon interest rate. Yeah, very good. GDP interest on interest rate, because you know that nowadays GDP of India is going down, है ना? तो अभी आप देख रहे हैं कि इंडिया की जीडीपी कम होती जा रही है. तो गवर्नमेंट क्या कर रही है जीडीपी को इंप्रूव करने के लिए? तो अगर आप न्यूज देखें तो गवर्नमेंट जीडीपी को इंक्रीज करने के लिए कौन से स्टेप उठा रही है? जीडीपी इंटरेस्ट रेट डाउन कर रही है. तो ये कॉमन सेंस का सवाल है, और इसमें डेवलपिंग और डेवलप्ड कंट्री का कंसेप्ट नहीं आता. कंसेप्ट सिंपल सा ये है कि इंटरेस्ट रेट अगर कम होंगे तो लोग लोन ज्यादा लेंगे, जीडीपी बढ़ेगा. सो इन ऑर्डर टू इंक्रीज द जीडीपी, the government is decreasing the interest rate so that everybody will take loan, and it will increase the spending in the economy, and as a result GDP will increase. तो GDP को संभालने के लिए इंटरेस्ट रेट कम किए जा रहे हैं. तो I can say that GDP depends upon. So now the relationship is that interest rate is causing the GDP. Okay, interest rate is causing the GDP. This is the relationship we understand. Okay, now, so in this way, first thing, what is the correlation between the two variable? We expect negative correlation. Second, can we explain the logical explanation between the interest rate and GDP? Yes, there is a logical explanation. So causation is there. Causation is there. And third, can we apply the regression between the GDP and interest rate? Yes. So this is the sequence of the relationship between correlation, causation, and regression. Okay. So now tell me some idea about the causation, correlation, and regression comes in your mind, or should I give some more examples? Okay. Regression, I will explain in detail, so don't worry. But I am telling you that why we are going to apply regression and why we stick to the correlation. Okay, now I am telling you one more example. I think after that it will be clear. So I have two variables again. Let's say x1, okay, x1 and x2. And x2 is number of corona patients in India. Number of corona patients in India. X2 is the temperature in India. Temperature in India. And I have daily data. I have daily data. And I have the daily data from 1st February to let's say 7th June. और 8th June, आज 9 तारीख है तो हमने 8 तारीख का डेटा ले लिया, मान लीजिए. So I have two variables. Number one, number of corona patients in India and temperature in India. I have the daily data from 1st February to 8th June. So tell me one thing. What is the correlation between the x1 and x2? कौन सा correlation होना चाहिए? यहाँ पर जनरल नॉलेज की जरूरत नहीं है, कॉमन सेंस. क्योंकि 1st फरवरी से 8 जून तक टेम्परेचर इंक्रीज हुआ है और कोरोना पेशेंट भी इंक्रीज हुए हैं. सो द कोरिलेशन बिटवीन द टू वेरिएबल्स इज पॉजिटिव. सो देयर एग्जिस्ट पॉजिटिव कोरिलेशन बिटवीन द टेम्परेचर एंड द नंबर ऑफ कोरोना पेशेंट्स. नाउ माय सेकंड क्वेश्चन, कैन यू से the temperature in India increases because corona patient in India increases? क्या हमारी कंट्री में टेम्परेचर इसलिए इंक्रीज हुआ है कि कोरोना पेशेंट इंक्रीज हुए? नहीं, बिल्कुल सही बात है. अच्छा, कैन वी से दैट कोरोना पेशेंट इंडिया में इसलिए इंक्रीज हुआ है कि टेम्परेचर इंक्रीज हुआ है? सो बिल्कुल सही आंसर. सो देयर इज नो लॉजिकल एक्सप्लेनेशन बिटवीन द टू. No logical explanation. So we can say there is no causation. There is no causation between the two. So it means, can we apply the regression model between the two? No, we cannot apply the regression model between the two because there is no logical explanation, logical relationship between the two. So I hope now after these three examples you have clarity between the correlation, causation and regression. So मेरा जो कंक्लूजन है वो ये है. व्हाट इज माय कंक्लूजन? रिग्रेशन इज एप्लीकेबल ओनली इफ देयर इज अ सिग्निफिकेंट कॉजेशन. There is a significant causation between X and Y. Yeah, so this is my take on the correlation, causation and regression. So first conclusion that you should have, first clarity, that regression is only applicable. Regression is only applicable when there is a significant causation between X and Y. So I hope now you know that why regression is required. Regression की required कब होती है? जब x और y में variables के बीच में significant causation होता है. Significant causation means there is some theoretical or logical explanation between the two. Now let's take some other example. अब मैंने एक variable लिया, variable number 1 is sales. Variable number 2 is advertisement. अब मुझे एक बात है, now tell me one thing. If I have the data of sales or an advertisement of different companies, what kind of relationship you are expecting, positive or negative? बिल्कुल ठीक है. So all of you are saying that there exists positive relationship between the sales and advertisement, right? Question number 2. Can you explain the relationship between the sales and advertisement? Can you have the logical relationship between the sales and advertisement? भाई advertisement ज्यादा करोगे तो sales ज्यादा होगी. So logical relationship है या नहीं है? है. Causation होगा या नहीं होगा? होगा. So there exists significant causation between the two. तो causation होगा तो regression लग सकता है? लग सकता है, बिल्कुल लग सकता है. तो अब regression लगाने के लिए आपको मुझे बताना पड़ेगा कि कौन सा डिपेंडेंट है, कौन सा इंडिपेंडेंट है. Which variable is dependent variable and which variable is independent variable. So think, use your common sense and tell me which variable is dependent and which variable is independent. So all answers are right. So I write the equation in this way, that sales is equal to alpha plus beta into advertisement. So this equation is known as a regression equation, where sales is my dependent variable and advertisement my independent variable. So in this way we define that sales is equal to alpha plus beta into advertisement. This relationship is known as regression model. Okay, now I start with this example and will explain you each and everything. So I am writing that y, अच्छा इसको sales से ले लेते हैं. Sales is equal to alpha plus beta into advertisement. So this is my regression model. This equation is known as regression model. This regression model is known as bivariate regression model because there are only two variables. So there are some. This regression model is known as bivariate regression model. Bivariate क्यों? Because why bivariate? Because there are only two variables. Because there are only two variables. One is sales and one is advertisement. So there is a bivariate regression model. बिल्कुल ठीक है. अच्छा, अब आपको ये तो क्लियर हो गया कि बाइवेरिएट हो गया. हटा देते हैं इसको. Okay. Then this variable is called dependent variable, and this variable is known as independent variable. So first of all, you should understand how we decide the dependent variable and how we decide the independent variable. Okay, so this is also clear. अब इसमें मेरे ख्याल से कंफ्यूजन नहीं होगा कि डिपेंडेंट कौन है, इंडिपेंडेंट कौन है. डिपेंडेंट आपका हमेशा लेफ्ट हैंड साइड होगा और राइट हैंड साइड आपका इंडिपेंडेंट होगा. ओके, अब समझते हैं अल्फा और बीटा को कि अल्फा और बीटा क्या चीज है. ओके, नाउ come to alpha and beta. So first, alpha is a constant. Alpha is a constant, and this constant is known as intercept. Alpha is a constant, and this constant is known as intercept, and this is ये alpha क्या है? Suppose if I ask you, suppose some company is not doing advertisement at all, so advertisement is 0. So what is the value of alpha? Sales. So alpha is the sales, is the level of sales when advertisement is 0. So we define alpha as the value of y when x is 0. So the definition of alpha is that value of dependent variable. Alpha is that value of dependent variable when independent variable is 0. So this is the definition of alpha. So you can see this. Alpha is known as a regression constant. It is called intercept. It is that level of sales when advertisement is 0, and in general it is the value of y when x equal to 0. Okay, so now again I am showing you one thing more, how to represent alpha. Basically, this is the regression line. This is the regression line, and now I am asked, this is x and this is y. अब यहाँ पर x 0 कहाँ पर होगा? So at which point x is 0? तो आप बोलोगे भाई x तो 0 origin पे होता है, तो x 0 कहाँ पर है? यहाँ पर है. So when x equal to 0, what is the value of y? This is the value of y. So this distance is known as alpha. So this in the graph we define the alpha like this. So you can see that alpha is 0, and where x is 0, alpha is that value of y when x equal to 0. ठीक है? अब alpha के बाद हम समझते हैं y को. Now come to beta. अब alpha समझ में आ गया आपको, अब beta समझ लेते हैं जरा. Beta. So what is beta? Beta is the change in y. Change in y when change in x is equal to 1 unit. When change in x in 1 unit. So if suppose advertisement increases by 1 unit, how much sale will increase? So this relationship is known as beta. Beta क्या है? Beta is the rate of change of sales with respect to. So we can say that change in sales upon change in advertisement is called beta. This is also known as dy upon dx. Rate of change of y with respect to x. So beta को हम क्या कहते हैं? Beta is known as slope. Beta is known as slope coefficient. Beta is known as slope coefficient. It is the change in y when x changes by 1 unit. So this is also known as rate of change of y with respect to x. In this equation, we can say that the beta is the rate of change of sales when advertisement changes by 1 unit. So this is called beta. And how we express the beta? Now I'm showing you how to represent the beta. Okay, now let's in this equation, this is x advertisement and this is sales y. So if this is the change in x, and this change in equal to 1 unit. So what is this? This is the change in y. So this change in y is equal to beta. So right, I said you that what is beta? Beta is equal to delta y upon delta x, and because delta x equal to 1, so beta is equal to delta y when delta x equal to 1. So this is the way we define the beta. So beta is known as slope coefficient. beta is known as slope coefficient. It tells you that if you change independent variable by 1 unit, how much dependent variable will change. Okay, so अब थोड़ा सा example भी ले लेते हैं जरा. So just see this, and I explained you alpha and beta, and say yes if you understand this, so that I can move further. Okay, understood. बहुत बढ़िया. So आप सारे आंसर yes आ रहे हैं. It means you understand this. Now I am taking your test. Suppose the alpha is 2000 and beta is 80. We have a equation that sales is equal to 2000 plus 80 into advertisement. After calculating, we found that alpha is 2000 and 80 is this. The sales is measured in units, number of units sold, and advertisement in rupees 1000. Right? The unit of advertisement is rupees 1000, and this is the sales is given to you is 2000. अब मुझे common sense से बताइए कि how you define alpha and beta. So let me listen carefully. The alpha is 2000 means when there is no expenditure on advertisement, the company will manage to sell 2000 units. Okay, so just look at this. अगर कंपनी एडवर्टीजमेंट पे एक भी रुपया खर्च ना करे तो कंपनी कितनी सेल कर सकती है? कंपनी करेगी 2000. So it is a constant. So even if company don't do any expenditure on the advertisement, company is able to sell 2000 units. Clear हो गया? So in this way we explain the alpha. Okay, बहुत बढ़िया. आपके सारे आंसर इतने गजब आ रहे हैं कि मैं खुश हो गया. मतलब great. Now second is, I'm asking second thing. If company increases advertisement by 1000 rupees, if company increases advertisement by 1000 rupees, how much sale will increase? How much sale will increase? Okay, no, so here your answer is wrong because the unit of advertisement is rupees 1000. So 1 rupee means 1000 rupees, right? If company increases the sales by 1000 rupees, the company sale will increase by 80 units. अगर company 1000 रुपए खर्च करती है तो 80 units और increase sales हो जाएंगे. So sales will increase by 80 units when company increases the advertisement by 1000 rupees, right? So basically, as I told you, the unit of advertisement is 1000. अगर data जो होगा हमारा data वो ऐसा होगा, sales 20, 201, 302 ऐसा data होगा. So 1 means 1000, 2 means 2000. So it means so that's why I told you if advertisement increases by 1 unit means 1000. Then the sales increases by 80 units. So this is in this way we explain the value of alpha and beta. So I hope now you have clarity on alpha and beta. Now I am asking you another thing. मुझे लगता है कि अल्फा बीटा समझ में आपको आ गया होगा. अगर आप नहीं आया अभी तक आपको समझ में, तो फिर आपको कोई दूसरा समझा नहीं सकता. चलिए, अब मैं आपसे एक चीज पूछना चाहता हूं कि is there any method available which can tell me that how much sales I can explain on the basis of advertisement? मुझे ये जानना है कि मैं एडवर्टीजमेंट की मदद से सेल्स को कितना एक्सप्लेन कर सकता हूं. What is the explanatory power of the model? So I am asking simple question. I am asking very simple question that how much sales can be explained. अब ध्यान से सुनना है इस सवाल को. How much sales can be explained with the help of advertisement? Now this is a question mark. So how much sales can be explained with the help of sales? Now here the answer is R square. अब आप सोचोगे कि R square क्या है? Now what is this R square? ये R का स्क्वायर है. R square. So this R square is very important in regression model. Now I am going to explain you what is this R square. R square is known as the explanatory power of the model. R square is known as explanatory power of the model. It is not the predictive power, it is called explanatory power. Predictive power तो हम कहीं और से निकालते हैं. It is not predictive power, it is called explanatory power. Okay, so now the next 5 minutes I will spend on R square. Okay, let me explain you the R square. Suppose this is sales. ये हमारा क्या है? Sales है. And this is the advertisement. Now sales is divided into two parts. You can see that the sales is divided into two parts. So this is the part of sales. ये sales का एक part हो गया और ये sales का दूसरा part हो गया. ये blue color का है. ठीक है? Now this is the blue color. Now sales is divided into two parts, red color and blue color. Okay, so now how I define this red color and blue color? So red color is known as common variance. This is known as common variance, which means variance in sales that can be explained by advertisement. ये मैं लिख रहा हूं क्योंकि बड़ा important concept है. Explained by advertisement. Now this is the common variance. Common variance means this much of variance of sales can be explained by the advertisement. और ये क्या है? This is called unique variance. Unique variance means cannot be explained by advertisement. So there are two type of variance of sales. One variance which can be explained by the advertisement and the other variance which cannot be explained by the advertisement. अब इसमें R square कौन सा होगा? रेड वाला या ब्लू वाला? अब इसमें बताइए R square क्या है? रेड है, ब्लू है? R square कौन सा वेरिएंस है? R square कौन सा वेरिएंस है? जो एडवर्टाइजमेंट से एक्सप्लेन हो रहा है या एडवर्टाइजमेंट से एक्सप्लेन नहीं हो रहा है? So all of your answer is good. I am happy, and this is known as R square. This red portion is called R square. So now what is R square? R square is the explanatory power of the model. Explanatory power. Explanatory power का मतलब होता है कि हम how much dependent variable can be explained with the help of regression model. R square means how much variance how much variance of dependent variable can be explained with the help of independent variable. So this is simply known as R square. तो R square आपको क्लियर हो गया कि भाई R square क्या होता है, बड़ा इंपॉर्टेंट कंसेप्ट होता है R square. So R square can be explained as the common variance, the variance in dependent variable, which can be explained with the help of independent variable. Okay, after adding this R square, now I'm telling you to one or two things more. Okay, so now come to F statistic. अब मेरा सवाल क्वेश्चन क्या है, right? How can I say that my model, my regression model is statistically significant? अब मेरा जो अगला सवाल है आर स्क्वायर के बाद वो ये है, how can I say that my regression model is statistically significant? मैं कैसे कह सकता हूं? अब इसका आंसर क्या है? The answer is that we have to check the F statistics and its probability value. So now I am going to explain you what is F statistic and its p value. Okay. So one thing which should be clear at this point is that what is the question which is answered by F statistic and its p value. F statistic आपको कौन से सवाल का उत्तर दे रहा है? कौन से सवाल का? कि क्या मेरा रिग्रेशन मॉडल स्टैटिस्टिकली सिग्निफिकेंट है? तो उसका आंसर कहां से मिलेगा आपको? F स्टैटिस्टिक से. तो F स्टैटिस्टिक क्या होता है देखते हैं. Okay. Now basically you have to understand one thing. This is the regression line. This is the regression model. और इसको हम कहते हैं y is equal to alpha plus beta into x. Suppose this is the x value and I want to know that if this is the x value, what is the value of y when x is x1? जब x की वैल्यू x1 के बराबर होगी तो y की कितनी वैल्यू होगी? y की वैल्यू कितनी होगी? इतनी होनी चाहिए, इतनी होनी चाहिए. मैंने बोला दिस इज द प्रिडिक्टेड वैल्यू ऑफ y. इसको हम कहते हैं y हैट. y हैट का मतलब है प्रिडिक्टेड वैल्यू. जब x की वैल्यू इतनी होगी तो y की वैल्यू इतनी होनी चाहिए. Predicted value of y. This is the predicted value of y. All predicted values comes on the straight line. Now my question is that is the actual value is also equal to predicted value? क्या ये जरूरी है कि actual value भी predicted value के बराबर हो? क्या actual value predicted value के बराबर होगा? भाई होगा ही नहीं. नहीं तो अगर हम prediction 100% कर लें फिर तो हम एक ही दिन में अमीर बन जाएंगे. तो prediction 100% accurate तो हो ही नहीं सकता. तो this is your actual value. Suppose this is your actual value y. The difference between the actual value and predicted value is known as error. Error. So this is called error, right? अब आपको ये clear हो गया होगा. Now you have clear. I think you have clarity that what is the error term. Error term is the difference between the actual value of y and the predicted value of y. And this error is also known as residual value. So this error value is known as residual value. So what is this error value? Error value is the difference between actual value of y and the predicted value of y. The error is known as the difference between actual value and predicted value of y. Now tell me one thing with your common sense. Higher the error is good or lower the error is good? Lower the error is good. Very good. Okay, so basically the F statistic is calculated from error. F statistic is calculated from this error term. F is calculated from error term, right? And second thing, F is equal to the if you want to see the formula, actual y minus predicted y square upon k minus 1, this is equal to y minus y mean. Okay, no, this is y cap on n minus k. So basically this is the formula for F statistic, and you should not see it, otherwise you will have a confusion. आपको इसको देखना नहीं है, मैं सिर्फ आपको ये समझा रहा हूं कि lower the error term, higher will be F statistic. So one thing which you should understand, ये formula भूल जाइए, ये mathematicians का काम है formula याद करना, आपका काम नहीं है formula याद करना. So don't worry. So you have to remember what? Lower the error term, higher will be the F. So now I want to know, is there any cutoff value of F? Yes. So if F value is greater than 4, P value less than 0.05, then you can say your regression model is statistically fit. So this is the concept which you want to know for today. जब F की value 4 से ज़्यादा होती है, when F value is more than 4, the probability value is less than 0.05, then we can say that the regression model is statistically fit. So lower the error, higher is the F value, and if F value is more than 4, it means the model is statistically significant. अगर F की वैल्यू 4 से कम होगी तो हो सकता है कि आपका मॉडल इनसिग्निफिकेंट हो जाए. So if you, this is the approximate value. The exact value of F is 1.96 square. The exact value is 1.96 square, but approximately it is coming to 4. Okay, so now I hope you understand this. How to interpret F statistic in the regression model. So you have to check whether the model is significant or not. You can analyze by analyzing the F value. Okay, so मेरे ख्याल से if anything is problematic in this slide, I will explain you. Forget n, forget k, forget anything else. That are the mathematical values. Okay, now the last value which I am going to explain is T statistic and its P value. Okay, आप लोग मुझसे पूछ रहे हैं कि P value क्या होती है. आप P value जिनको नहीं पता वो अपना लैपटॉप बंद कर दें और वर्कशॉप से निकल जाएं, क्योंकि P value तो अगर आपको नहीं पता तो रिसर्च करने का कोई फायदा नहीं है. P value is the probability value which is decided for hypothesis testing. And now I am going to the last value of, then I will show you the T statistic. Basically, this is the regression model. This is the regression model. And my question now is, can I say, now see the question, can I say that X is having significant impact on Y? Now see the question, can I say that X is significant? Okay, can I say that X is having significant effect on Y. Can I say that X is having significant effect on Y? Or basically, I am testing the null hypothesis that this beta equal to 0. Can I say that beta is equal to 0? So basically, all the regression equation solve this hypothesis, examine this hypothesis with the help of T statistic. So now I am applying a formula T statistic, and how I conclude. So listen how I conclude. If T statistic is greater than 1.96, it means hypothesis rejected. Hypothesis rejected. So you have to understand, और ये चीज आपको बिल्कुल याद होनी चाहिए कि जब भी whenever the T value is more than 1.96, whenever the T value is more than 1.96, null hypothesis will be rejected. Null hypothesis will be rejected. So आप अपनी कॉपी में ये लिख लीजिए, please note down this value. आपको दो चीजें लिखनी है. Number one, when F statistics is more than 4 and T statistics is more than exactly 1.96, then model is significant and X is having significant impact on Y. Okay. So after this, after explaining all these things, now I'm showing you the analysis in regression SPSS. So let's move to the SPSS part. And in SPSS, I'm showing you the all these things, how to do this. So give me 1 minute to open the file. Okay. Now I am showing you the how to perform the regression analysis in SPSS. This is income and this is consumption. I have to decide that which variable is independent variable and which variable is dependent variable, right? If you want to open the file, you have to open the SPSS. You should have the SPSS and open this file from SPSS. Okay. So yes, you are saying that consumption is dependent. Very good, very good. Consumption is dependent and income is independent, right? So now your mind is working properly. Good. Consumption is dependent and income is independent. Great. Now see the commands. Analyze regression linear. Analyze regression linear. Yes. It is also true for time series. That is not a problem. Now in linear, I have to tell the software that consumption is my dependent variable and income is my independent variable. Consumption is my dependent variable, income is my independent variable, and now I'm clicking OK. And I hope the analysis is in front of you. Now I am asking you whatever I am teaching you, whether you understood or not. So the R square of regression model is 90.5. The R square is found to be 90.5. Okay. Okay, so you are saying me कि steps आपको दोबारा दिखाए जाएं. Okay, no problem. See the steps again. Go to analyze regression linear. This is analyze regression linear, and I explain consumption here. I explain income in independent, and after explaining the consumption and independent income, right, I click OK. And after clicking OK, I am getting this answer. Now I am asking you whether you understood my lecture or not. How to explain R square? How to explain R square? 90.5%. R square is 90.5%. जो मैं सवाल पूछूंगा सिर्फ उन्हीं का आंसर देना अभी आप, बाकी चीजें हम नेक्स्ट लेक्चर में करेंगे. तो R square 90.5 means the 90.5% of the variance of consumption can be explained by the income. Very good. आपका आंसर बिल्कुल सही है. So 90.5% of the variance of consumption can be explained by income. That's fine. अब आ जाते हैं सेकंड इक्वेशन में. सेकंड इक्वेशन में f की वैल्यू कितनी है? The value of f is 554. The value of f is 554 and significance value is 0.000. Now tell me, write in the chat box that how to interpret this. Yeah. So Neha is right, Bindu is right, Shweta Tomar is right, Lakwinder is also right. Statistical significant, yes, significant. So basically what I am interpreting from here is that because my f value is more than 4 and higher it is, better it is. 4 is the minimum required value. 4 is the minimum required value, remember, and higher is the value of f, better the model is. So it means I can say that my regression model is significant. My regression model is statistically significant, right? My regression model is statistically significant. Very good. Okay. Now let's come to the t statistic. अब आप मुझे बताइए, what is the alpha in this equation? What is the alpha in this equation? अल्फा कितना है इस इक्वेशन का? अल्फा कितना है? What is the alpha value of this equation? 17. Yes, the alpha of the equation is 17. Very good. So this value is 17 and income is on B. How much is beta? How much is beta? Alpha is 17 and beta is 0.6. Beta is 0.6. Beta is not 600. Beta is 0.6. So how can we interpret the alpha and beta? अब ये alpha and beta को interpret कैसे करें? So मैंने आपको समझाया था. So I explained you what is the alpha. Alpha means alpha is that value of the dependent variable when independent variable is 0. It means if income of a person is 0, how much money he require for consumption? If income of a person is 0, how much the person require for consumption? 17 rupees. So in this way we explain the intercept. Very good. Now beta of the equation is 0.6. Beta of the equation is 0.6. Beta of the equation is 0.6 means when income increases by 1 rupee, consumption increases by 60 paisa. When income increases by 1 rupee, consumption increases by 60 paisa. So this is the relationship between income and consumption. We can also say that if income increases by 100 rupees, consumption increases by 60 rupees, like this. Okay. And now the last value is t statistic. The t statistic is 23. Now I already explained you that if t statistic is more than 1.96, if t statistic is more than 1.96, then we can say there is a significant effect of x on y. It means income is having a significant impact on y. Because my t statistic is more than 1.96, so I can say there is a significant effect of income on consumption. So this is the simple bivariate regression model I explained you, and I think 15 minutes are given for query asking. So now I open for the query. If anything is not clear, I will answer you. Anu ma'am, hello.
Hello.
Yes ma'am.
Hanji sir.
You said that there is 1 hour for lecture and 15 minutes for query. Is it right?
Sir, yes, sir. Actually, most of the queries have been answered, but still, if people there chat box used to ask the queries, I will open the chat box for the question answer session. So two or three questions are there. I'll be asking for them.
Yes, yes. Now, actually, no. I'm just asking that according to the session, 1 hour for session
Yes.
and 15 minutes for query, right?
Yeah, sir. Yeah, sir.
So now I am
so
open
yes.
for the answers, and if somebody want to ask their query, so what is the way they will put their query in the chat box, or they can ask by unmuting?
So they'll be putting their queries in the chat box.
Okay, actually the chat box is moving like a rocket.
Sir, actually 2-3 questions are there. I'll be putting them up. Dr. Sandeep Gupta has asked, what is the difference between correlation and simple regression? Linear regression.
Correlation only tells you that whether the two variables are having relationship or not. Now, actually, I am giving you one example. Dr. Sandeep Gupta, उनको एक answer मैं पूछ रहा हूँ. Suppose you are having the two variables like your age and the height of a tree. उनके बीच में correlation होगा या regression होगा? I am asking very simple query. You are having the two variables, your age, the data of your age, and the height of a tree. So what analysis you can apply between them, correlation or regression? So answer is that correlation we can apply because correlation don't require any logic, but regression cannot apply because logic is there. So अब देखिए आपकी height, पेड़ की हाइट इसलिए थोड़ी बढ़ी है कि आपकी एज बढ़ रही है, तो लॉजिक नहीं है, लॉजिक नहीं है तो रिग्रेशन नहीं चलेगा. Regression you can apply when logical relationship is there. If there is no logical relationship, you can stick to up to the correlation. You cannot apply the regression between them. Okay. So I think it will be clear.
So yes. So next question is from Sonal Gupta. What is the difference between standardized and unstandardized beta?
Okay, basically there are two types of beta. One is standardized beta and the second is unstandardized beta. And let me explain you one thing, because ये concept जो है वो next lecture मेरे आने वाला था, लेकिन पूछ लिया तो मैं बता देता हूँ. There are two types of beta here. One is called unstandardized beta and second is standardized beta. जो लोग स्टैटिस्टिक्स में पहली बार आते हैं ना, तो बीटा को बीटा भी कह देते हैं. खैर, basically number one, used for prediction, and this is used for comparison. Number one, regression applicable on X and Y in units, and this is regression on Z scores of X and Y. Number three, alpha is important here. Alpha is equal to 0 here. And number two, it depends the regression or beta depends on units and beta is unit free. Unit free means now the unit is standard deviation. Okay, now I explain you. Unstandardized beta is used when you want to predict, And standardized beta is used when you want to compare. Compare means which variable is having more effect on y and which variable is having less effect on y. So if you want to compare that, like for example, I know that stress is coming for two. Suppose stress is coming for two reasons. One is the income, and second is the age, right? And I want to know that which variable is causing more effect on stress, age or income. Then I will see standardized beta. If I want to predict how much is the stress come, then I will use unstandardized beta. Unstandardized beta is used for prediction, and standardized beta is used for comparison. And when we apply regression model on the original value of x and y, then we get unstandardized beta. And in standardized beta, we convert the x and y values into z scores and then calculate the beta that is called standardized beta. Standardized beta equation में alpha हमेशा 0 होता है और unstandardized beta के साथ alpha हमेशा 0 नहीं होता. Beta units पे depend करता है और standardized beta unit free होता है. For example, if income increases by 1 rupee, consumption increases by 0.6. So basically, we define the beta in terms of units. But when we say standardized beta means when income increases by 1 standard deviation, consumption increases by standardized beta times. So we defined beta and standardized beta like this. I think it is clear.
Thank
Otherwise,
you, sir.
I am going to explain in the next session in detail.
Sure, sir. So next question is from Dr. Kavita. What is the use of standard error?
A standard error is used for the prediction actually. जैसे मान लीजिए, for example, you are applying for a job. मैं आपको बड़ा simple सा example दे रहा हूँ. You are applying for a job and you ask that what could be my salary. And if the boss says your salary maybe between 20,000 and 2 lakhs, right? And then you applied for a second job, and the boss say that your salary is between 1 lakh and 1,50,000. So which is much better? Wherever the range is less, then that is much better. Basically, you know that there is a concept called mean plus minus 1.96 into standard error, right? So if you take plus, this is called upper limit. If you take minus, it is called lower limit. So this range, lower limit and upper limit, this is the average beta. So average beta, like for example, in our equation, the average beta is 0.6. And if the lower limit is 0.2 and 0.9, or if the limit is 0.5 and 0.7, so which is better? I think the prediction is better in this case. So ये जो lower limit और upper limit decide होती हैं, वो standard error से होती हैं. तो standard error जितना छोटा होगा, lower the standard error, your prediction will be more accurate then. So standard error is the measure of your prediction accuracy. Higher the standard error, less will be the prediction accuracy, and lower is the standard error, more will be the prediction accuracy. So this is the standard error is basically measuring the prediction accuracy.
Thank you, sir. So next, some questions are there regarding the interpretation. So Dr. Mahesh is asking how to interpret adjusted R square.
वो next session में आएगा मेरे.
Okay, fine. Sir, one more question is.
हाँ.
Sir, Dr. Asin is asking, what is the causal effect on exploratory research?
मैडम एक्चुअली बताइए ना, ये कॉजल और एक्सप्लोरेटरी ये तो साउथ और नॉर्थ है, ये दोनों एक साथ कैसे होंगे?
ओके.
आप तो ये पूछ रहे हो कि चेन्नई में दिल्ली के आसपास कैसे ले आऊं?
Sir, actually she has put up this question.
Yeah, basically exploratory is different thing and causal research is different thing. You cannot mix them. They are entirely different.
Okay, sir. Sir, one more question. Can we use SPSS in time series data?
No.
Okay.
SPSS is not meant for time series. SPSS is not meant for time series. SPSS is only for cross-sectional data. And if you are having the time series data, better you go for eViews, Stata, R, or any other software. So don't use SPSS for time series, because in time series the basic test is unit root test, right? And in SPSS we can't apply unit root test. So when you can't apply basic test in SPSS, what is the use of applying SPSS for time series?
Okay. Thank you, sir. So next question is from Anisa. She wants to explain T-score.
T-score.
Yeah, sir. T-test, I think so.
T-test. I think they are asking for T-test.
Yeah.
Basically,
T-test, yes,
T-test is measuring. T-test is measuring the hypothesis that your beta is equal to 0. And if T value is greater than 1.96, we can reject the null hypothesis. We can reject the null hypothesis. So this is the use of T-test in regression model. Beta equal to 0 means X is not causing effect on Y. And we can reject it if T value is more than 1.96. So this is the use of T-test in regression model.
Okay, sir. Sir, one question is from Dr. Angur Kumari. She says how to choose between Pearson and Spearman correlation.
Pearson is parametric correlation and Spearman is non-parametric correlation. So सीधी सी बात है कि when you want to apply the correlation between the scale variables, then you have to apply the Pearson correlation. And when you want to see the correlation between the ordinal variables, then you have to go for a rank correlation or Spearman correlation. But Pearson correlation is the parametric correlation, can be applicable only with the scale data. And when you have the non-ordinal data, ordinal variables, then you can apply Pearson correlation.
Okay. Sir, Miss Deepa Ahuja is asking, sir, can you please repeat the diagram and X and Y relationship again? Only predicted value diagram.
Predicted value diagram. आपको तो वैसे video
Yes,
lecture मिल ही जाएगा तो
sure, sir, please.
Let me explain you this. Basically, the regression model is regression line is coming like this. Just one more time. This is the regression line, and if suppose this is the value of X, and for this value of X, the predicted value of Y always lie on the straight line, and the actual value is different from the predicted value. The predicted value is represented by the Y hat, and the difference between actual Y and predicted Y is called error. So lower the error, better it is. So this is the diagram.
Okay. Sir, one last question.
Yeah.
Any Mahajan, how to use Granger causality for caution?
Granger causality is not related to this, because Granger causality we can apply only between the time series, and there is a different treatment of time series in eViews. We cannot apply the same technique in time series method, because in time series we have to check the unit root and check the stationarity and the check so many other things like structural break and so on. Then we can go for Granger causality. So that is a different treatment, and if there is a special lectures on time series, then I can explain you. Otherwise, there is no point of explaining the Granger causality in regression model.
Thank you, sir.
Yeah.
So no more questions are there. We can meet after 15 minutes at 11:30 for the second session.
Yes. Thank you, ma'am. Thank you.
Thank you, sir. Ravinder?
Yes, ma'am.
Hello. Ravinder,
Yes.
please break for 15 minutes, then we'll meeting at 11:30 again.
Fine. A request to all the participants, please do not leave this meeting. We'll be connecting in the same meeting. So we'll see you after 15 minutes at 11:30. Thank you.
सरस्वती शारदा, हे माता सरस्वती शारदा, विद्यादानी दयानी दुःखहरिणी, जगत जननी ज्वालामुखी माता सरस्वती शारदा, हे माता सरस्वती शारदा, विद्या
Okay, welcome back. So I hope we can start.
So just wait for a while. Sir, yes, we can. Ravinder, can we start?
Yeah, sure.
Sure. Yes, sir.
Okay. Now we are moving slightly ahead, and so I am writing here that y is equal to alpha beta 1 x1 and beta 2 x2. So we are moving to the more number of variables now. So we are having one dependent variable, and we are having two independent variables. So we are having two independent variables here, one dependent and two independent, and this is called multivariate regression model. Multivariate means when independent variable are more than one. When independent variables are more than one, then we are having multivariate regression model. So I hope you understand what is the difference between bivariate regression model and multivariate regression model. Okay. So after this, now I am going to explain you what is the different thing which now we are going to add here. So I hope you understand what is the bivariate and multivariate. After understanding the bivariate and multivariate, now let's move further. Okay. So remove this also. The question is that we already have this equation. Why to add this x2? Right? Why to add this x2? First question I am asking, question number 1. Why to add more independent variables? Why to add more independent variables? The answer is to increase explanatory power of y using regression model, because we want to explain y more. हमें y को ज़्यादा explain करना है. So in order to explain y better, in order to explain the dependent variable better, we are adding the more independent variables. So this is the reason of going from bivariate to multivariate, because we want more explanation of the independent variable. Okay. Now after that, what happens when we add a new variable? क्या होगा, मतलब क्या होगा कि जब हम नया independent variable add करें? So what will happen when we add a new variable into regression model? So let's see. Now I am saying that what will happen when we add more independent variables. Now the answer is R square always increases. The R square always increases. Now the problem is that when R square always increases, how we can identify whether the new variable is useful or not? जब हर वेरिएबल को बढ़ाने से जब सारे वेरिएबल्स बढ़ाने से, जब किसी भी नए वेरिएबल को बढ़ाने से आर स्क्वायर हमेशा बढ़ता है, तो कैसे डिसाइड करें, हाउ टू डिसाइड दैट वेदर वी शुड ऐड ए न्यू वेरिएबल और नॉट. So now this is the problem, right? So now the answer is that we have to check adjusted R square. We have to check adjusted R square. So now this adjusted R square is playing a very important role in regression model, right? So what is the criteria now? How to decide, how to analyze this adjusted R square? Now the question is that ये adjusted R square है क्या? ये क्या चीज है? What is this adjusted R square? So now I am going to the importance of adjusted R square, and so you will understand the importance of adjusted R square after this, after 5 minutes. Okay, so now let me delete this. So just before deleting, what will happen when we add more independent variables? R square always increases, so we have to check adjusted R square. How? Okay, so again I am writing, when we add a new independent variable, then there are two things. Number one, R square always increases. Number two, adjusted R square may increase, remain constant, or decrease. So there are three cases of adjusted R square. R square may increase, R square may remain constant, or R square may decrease. So on the basis of adjusted R square, we have to decide whether we should add a new variable or not. If R square also increases, if adjusted R square also increases, include the variable, include a new variable, and if it is constant, remove it, and if it decreases, remove it. So this is the concept of adjusted R square. Adjusted R square is nothing, it is the R square adjusted by the degree of freedom. Adjusted by the degree of freedom. Okay, so now I am going to demonstrate you this concept with the help of SPSS sorry, SPSS data file, and type in yes chat box if you understand it, and if not, then I will explain you again. अगर ये आपको समझ में आ गया, मतलब मैं आपको एडजस्टेड आर स्क्वायर समझा रहा हूँ, समझ में आ गया तो आप लिखो यस, नहीं आया तो मैं आपको दोबारा समझाऊंगा, क्योंकि because all of you are saying yes, so I am showing you in regression model. So let me share the SPSS file with you. So this is a SPSS file, and okay, you can see that there are these are the 5 variables here, and I want to explain the independent variable which is y. So rest of the variables I am deleting because I am not going to use it in this session. Okay, एक ज़्यादा ही delete हो गया. So let me delete all this. Okay, now my y is dependent variable. I change it name purchase. So purchase is my dependent variable here. And the purchase of the car, it is a purchase of the car, depends upon the financial sensitivity of the person, lifestyle of the person, leadership of the person, optimistic behavior of the person, innovativeness of the person, and family. So these are the independent variables in the regression model. So now I am going to apply the first bivariate model. Let's say I go to regression, linear, and purchase is my dependent. And suppose I start with any one variable, leadership. Okay, now just to start with, I take this variable. You can start with any variable, that is not a problem. Now, if you see the regression results, the R square is only 8%, 8.6%. Adjusted R square is 8.4%. F statistic is more than 4, very good. T statistic is more than 1.96, very good. So this model is significant. So we have to keep this model and we want to improve this model. So in order to improve, I am adding the more independent variables. So now I add first variable like finance. I am adding one more variable, finance. And the results is coming like this. Now you have to tell me with your understanding whether I should add it or remove it. Okay, so now tell me what is the answer. Neha is saying that we should remove the variable. Yeah, very good. And any other answer? मैं आपको समझा देता हूँ. So let's see this. First of all, when we add only one variable, when we add leadership, सबसे पहले हमने leadership को हमने add किया था, and after adding the leadership, it is only one variable. The adjusted R square is found to be 8.4%. R square is found to be 8.6%. And this is significant because F statistic is more than 4 and T statistic is more than 2. So because of this significance, we keep this variable, and after that I am adding. Okay, now after adding the new variable, this adjusted R square is what happens to adjusted R square? It decreases from 8.4 to 8.3. Now you can see adjusted R square increases by 0.002, but adjusted R square decreases by 0.01. So मैंने आपसे कहा था कि जब भी adjusted R square decrease होता है, हमें variable को remove कर देना चाहिए. देखिए आपका add करने से, after adding the new variable, adjusted R square decreases, F statistic also decreases. It means this variable is not good for equation. Remove it. So now I am removing it. After removing the financial, I am adding some other variable, lifestyle. I am adding some new variable. Okay. Now this is the result. Now adjusted R square increases to 17.6%. R square increases to 180, and F statistics increases to 43. So it means this variable is useful variable and we should keep it. Simple. Okay. So this variable, this is a regression model, is a good model because this variable is increasing the power of the regression model. This variable increases the explanatory power of the regression model. Okay. So I think this is clear. Now, similarly, I will add one more variable. Okay, now I am adding the optimistic. Leadership we already have, lifestyle we have. Now I am adding the optimistic. So just before adding, just note down the existing adjusted R square is 17.6. Adjusting R square is 18. And adjusted R square is 86. So what happened by adding one more variable? Okay, अब आप देखते हैं कि पहले हमारा कितना था? पहले हमारा था 17.6 and now it is 18.4. So it means you can see that this variable also increasing the adjusted R square. So we have to see what is the impact of adjusted R square. So whenever R square तो देखो हमेशा increase ही होगा. R square always increases. We have to check only the change in adjusted R square. So because the adjusted R square increases, so we have to keep it. Okay. Now this variable is significant or not, we have to check from here. All the T statistics are more than 1.96, so this variable is also significant. We should keep it. We should keep it. अब एक दो variable और बचे हैं. Let's see what is the impact. I want to add an innovativeness now. So before adding, I just check my existing R square is 18.4, and now I am going to add one more variable, and I'm going to add one more variable, and after that adjusted R square increases to बहुत ज़्यादा increase नहीं हुआ, so let me check it again. I add innovativeness, and after that this adjusted R square increases to 41%. Oh, very good. Now you can see that now after adding one more variable, my adjusted R square moved to 41. सीधा 18 से 41 पहुंच गया. So this is good. This is good. We should keep it. We should also keep it this variable. So now there are 4 variables in my regression model, and it is good. Okay. So after adding that, everything is very good. Adjusted R square increases to 41, and this variable is also significant. Okay. Now let me add one more variable, family. After adding, what is the effect on adjusted R square? Okay, what is the impact on adjusted R square? अगर आप देखोगे ध्यान से, adjusted R square पहले भी 41 था, ऐड करने से पहले भी 41 था, और ये अभी भी 41 है, अभी भी 41 है. There is no increase in adjusted R square. Should we keep it or remove it? Should we keep it or remove it? So answer is remove it. मैंने आपको बोला था कि जब if by adding a new variable there is no change in adjusted R square, don't include that. And you can confirm it by here also. You can see that family is insignificant. यहाँ पे t की value कितनी है? The t statistic is less than 1.96. तो t की value 1.96 से कम है तो remove कर दो, कर दिया. So now I am going to remove it. So I am going to remove the family. Okay, now this is the final regression model that I have to report in the research paper. Yeah. So now you can see that I have all significant variables, and adjusted R square is the maximum. This is my best of the regression model which I can make from here. And after this step, one thing should be clear, that what is the use of adjusted R square in regression model. This should be clear. If it is clear, say yes. Otherwise, then we go to the next part. Okay. So all the answers are coming yes, and one or two say repeat once more. Okay. So just see this, and what I write here, आप इसको एक बार पढ़ लो, आपको क्लियर हो जाएगा. मैंने आपको this actually I explained you. When we add a new independent variable, then R square always increases. Adjusted R square may increase, remain constant, or decrease. If it is increases, include the new variable. If it is constant or decrease, remove the included variable. So this is the concept I explained you, and now I am moving to the next part. Okay. So after this, the next concept is basically, if you see the results, we are having two beta here. This is unstandardized beta, and this is the standardized beta, right? Now tell me, what is the difference between unstandardized beta and standardized beta? So now we have to understand very clearly that what? Okay. So I hope it is clear and screen. Yeah. So now I am asking. Now my question is, listen my question. How to interpret standardized beta and unstandardized beta? So I am asking you some questions and you will answer. Number one, which variable is having the highest impact on the purchase behavior? Which variable is having the highest impact on the purchase behavior? Preeti madam is saying innovativeness. Yeah, very good, because how we can identify that which variable is having the highest effect? We have to check standardized beta. हमें क्या देखना है? Standardized beta देखना है. So the variable which is having the highest standardized beta is having the highest effect. Okay, so 0.475 is the highest. It means the innovativeness behavior of the consumer is having the highest effect on purchasing behavior. The second highest effect is found to be highest. तो हमने कहते चलो innovative है. Second highest, which is second highest? Lifestyle. So lifestyle, the standardized beta of lifestyle is the second highest. So we can say is after innovativeness, the lifestyle of consumer is having the highest effect on purchasing behavior. Similarly, after lifestyle, we are having the leadership. Leadership is the third highest, and optimistic behavior is the fourth highest. So in this way, we can identify that which variable is having the highest effect on X, Y, and which variable is having the least effect on Y. तो जब हमें comparison करना होता है, so when we want to compare the effects of independent variables on dependent variable, then how we analyze? We analyze standardized beta. We analyze standardized beta. So मेरे ख्याल से standardized beta clear हो गया. If it is clear, say yes. Standardized beta is used to find out which variable is having the highest effect and which variable is having the lowest effect. So all of you are saying yes, it means standardized beta is clear. Okay, now I'm giving you 3 or 4 examples. So you have to tell me which is important and which is not. So let me go for the whiteboard again. Okay, now I write equation number 1. I want to study the happiness, and I am applying the regression model like happiness equal to beta 1 into income plus beta 2 into health. Similarly, second is GDP is equal to alpha into beta into interest rate plus beta 2 into money supply. Number 3, job satisfaction is equal to plus beta 1 into employee engagement plus beta 2 into employee motivation. Number 4, the gold demand is equal to alpha plus beta into price of the gold plus beta 2 into interest rate. अब आप मुझे बताइए कि in which regression model standardized beta is important and in which model unstandardized beta is important. So you have to tell me that which is important, where standardized beta is important and where unstandardized beta is important. अब चलते हैं पहली वाली एग्जांपल पे. happiness is equal to alpha plus beta is equal to income and health. इसमें कौन सा important होगा, standardized beta or unstandardized beta? So basically here we want to see whether income is causing the happiness or health is causing the happiness, and which is causing more happiness. So in this case we are not going to predict, we are going to compare. So standardized beta is important. Similarly, in second case, all the equations in economics, we don't want to analyze that which is more causing the GDP. Yeah, this is important, but the most important is to predict. We want to predict the GDP because assuming that if next year interest rate is this, money supply is this, what would be the GDP? So here we want to predict, then it means for prediction, unstandardized beta is important. Similarly, in job satisfaction, we don't want to predict the job satisfaction. We want to see whether employee engagement is more important or employee motivation is more important. So this is known as importance of standardized beta in the regression model. Like in goal demand, because we do not want to find out that which is more important, we want to predict the demand. So whenever we want to predict the demand, it means standardized unstandardized beta is more important as compared to standardized beta. So in this way we can analyze that where or when standardized beta is important and when unstandardized beta is important. In finance and marketing, in finance and economics, the unstandardized beta play a very important role. However, in case of human resource, however, in case of social science, education, economics, not economics, marketing. So education, marketing, HR, social science, the unstandardized beta is more important. Okay, so I think now you have clarity. Job satisfaction equal to. So tell me, is it clear or not? So okay, I repeat once more. In the areas that economics, finance, unstandardized beta are more important. In the areas education, in marketing and like human resource, the unstandardized beta are not very much important. What is important is standardized beta, because we want to compare that from where effect is high, from where effect is low. So that's why in all these areas, like human resource, marketing, the standardized beta is more important. Standardized beta is more important. Okay, so let's go to the next concept. So I hope you understand that when you want to predict the demand, unstandardized beta is important, and when you want to see the behavior, so when standardized beta is important, when unstandardized beta is important, you can judge out using this. Okay, so now let's go to the next part. Again, whiteboard is useful. Okay, so I am telling you one more important thing. Like this is my regression model: alpha plus beta 1 plus beta 2 into x1 plus x2 plus beta 3 x3 and so on. Okay, now this x1, x2 and x3, these variables are known as independent variables. Independent variables. And all these variables are independent. So now my question is that what happens when these variables are not independent? These variables are dependent. What happens when these variables are dependent? Dependent means they influences each other. So this problem is known as multicollinearity. Multicollinearity. This is a basic problem in regression model. So just read this: multicollinearity. And multicollinearity means when independent variables which are assumed to be independent, but actually they are not independent, they are dependent. ठीक है? So this problem is known as multicollinearity, and I am going to tell you how to examine this multicollinearity and how to check whether the regression model is suffering from multicollinearity problem or not. Okay, so let's explain this. So multicollinearity problem is measured by VIF. This VIF stands for variance inflation factor. Variance inflation factor. And the variance inflation factor should be less than 3. So आपको इतना ही याद रखना है कि variance inflation factor 3 से कम होना चाहिए. Variance inflation factor is less than 3, and if it is less than 3, then we have no problem. If VIF is greater than 3, then it means we are having a problem. We are having a multicollinearity problem. So now I am showing you how to check this multicollinearity problem. Okay. So let's move to the so I am taking you to the SPSS file and show you how to check the multicollinearity. This is my regression model. Regression model is already here. Now I am clicking on the statistics. So you can see there is an option, and the option is called statistics. And I clicked on this option, and I click on the collinearity diagnostics. You can see here collinearity diagnostics. So I click on the collinearity diagnostics and continue, and okay. So in the results, you can see the value of VIF. You can see that we are having the value of VIF. Now, because VIF value is less than 3, so in this regression model, multicollinearity problem is not there. This regression model is not suffering from multicollinearity problem. So this way we can also identify whether the multicollinearity problem in this paper is there or not. Okay. So I think multicollinearity problem is clear. How to check multicollinearity? Multicollinearity होती क्या है? कैसे check करते हैं? ये आपको पता होना चाहिए अब. चलिए. So you are saying yes. आपको VIF की value दिख रही है, and all the VIF values are less than 3. It means there is no multicollinearity problem, and we are happy. Okay. If VIF is less than 3, it means the variables are not related to each other. Okay, next thing, now I am going to explain you autocorrelation problem. So let's understand what is autocorrelation problem, and then I will explain you how to test it in the SPSS. Okay, so let's move to the whiteboard, and so I clear all the screen, and I am showing you the second problem. The second problem is known as autocorrelation problem. Autocorrelation problem. ये problem है. That's why we call it autocorrelation problem. Actually, when error terms of the regression model are found to be correlated. When the error terms of the regression model are found to be correlated, this problem is known as autocorrelation problem. This problem is examined with the help of a statistic called Durbin-Watson statistic. Durbin-Watson statistic. So, and Durbin-Watson statistic, the ideal value is 2. Ideal value is 2. And we have, if dw is less than 2, this is called positive autocorrelation problem. And if Durbin-Watson is greater than 2, it is called negative autocorrelation problem. So this is the Durbin-Watson problem that we have in the regression model. I just repeat, what autocorrelation problem is one of the problem in regression model. When error terms of the regression model are found to be correlated, this problem is known as autocorrelation problem, and this problem is identified by the Durbin-Watson statistic. And the ideal value of Durbin-Watson statistic is 2. If Durbin-Watson is significantly less than 2, then this problem is known as positive, plus a positive autocorrelation problem. And when Durbin-Watson is more than 2, its problem is known as negative autocorrelation problem. So this is the concept of autocorrelation. And in autocorrelation, there is one more thing. Actually, this is the range of Durbin-Watson. 2 is very ideal value, but we never get the value of 2. So between 1.6 and 2.4, we can say no problem. And up to 1, this is called moderate problem. And this is called dangerous problem. So if Durbin-Watson is less than, is 0 to 1, 0 to 1, it is dangerous problem. 1 to 1.6, moderate problem. And between 1.26 and 2.4, it is no problem at all. So this is no problem. And after this, I have not seen in my life that Durbin-Watson is more than this. So it is not possible. Durbin-Watson की वैल्यू इस रेंज में आती ही नहीं है, मैंने आज तक जिंदगी में नहीं देखी, तो मैं इसके बारे में कुछ नहीं कह सकता. So this is the range of Durbin-Watson that we can have. So I repeat, between 1.6 and 2.4, it is no problem. 1 and 1.6, moderate problem, and 0 and 1, dangerous problem. तो देखते हैं अपने regression में क्या आ रहा है. So let's go back to the regression. अपने regression में Durbin-Watson को चेक करते हैं जरा. Okay, इसको maximize कर दिया. Now go to analyze and go to regression, linear. Now again go to statistics, and I am clicking here on Durbin-Watson. Continue. मैं एक बार फिर से कर रहा हूँ क्योंकि काफी लोग भूल जाते हैं. Analyze, regression, linear, go to statistics and click on Durbin-Watson. So this is the step. After that, you have to click OK. Dependent variable is here, independent variables is here, and after click OK. So you can see this Durbin-Watson value is 1.875. 1.875. So 1.875, it means this model is not having dangerous autocorrelation problem. So I hope now you have clarity that what is the meaning of Darwin Watson? Okay, screen आपको नहीं दिख रही है. मैं एक बार let me check it again. Yeah. So now you can see that. I hope you can see the screen and you can see the value of Darwin Watson. आधे लोग कह रहे हैं कि दिख रही है, आधे लोग कह रहे हैं नहीं दिख रही है. ये तो मेरे को समझ ही नहीं आ रहा है ऐसा क्यों हो रहा है. Okay, so I think it depends upon the speed of the internet of different. Those who are having good speed, they can see. Those who are not less speed, they cannot. Now, Darwin Watson is value is 1.875. The Darwin Watson value is found to be 1.875. So this is good or not? Yes, Richa Verma is saying there is no problem. Very good. So you can see that in this regression model, Darwin Watson is 1.875. There is no problem. And multi-collinearity bhi hamari VIF is also less than 3. No problem. Okay. So these are the two basic problems in the regression model that we have to check. Okay. Now I am going to tell you one thing which is not available in any book. Now I am going to tell you how to improve the adjusted R square of the model, because in most of the research papers, they are expecting that your adjusted R square should be greater than 50%. आपका जो R square है वो कितना होना चाहिए? More than 50%. Right. So now I'm going to explain you how to increase the adjusted R square from the regression model right? Okay. So now I'm going to explain you that this model is having how much adjusted R square? 41%. I want to increase it more than 50%. So what should I do? So now I'm going to tell you a trick. Go to analyze, regression, linear, and I am going to click on the save. ये जो save option है मैं इस पे click कर रहा हूँ. I am going to click on the save, and in the save I have different options, but the most important option is Cook's distance. So you can remember that Cook's distance is very important concept in regression model. ये वो जादू की छड़ी है जो मेरा R square 50% से ऊपर कर देगा. So अब मैं आपको दिखा रहा हूँ कि ये adjusted R square को कैसे improve किया जाता है. So now I click on the Cook's distance. I clicked on the Cook's distance. Click continue. Click continue. And okay. So after this, I can see in the data that I have this new variable called Cook's distance. Okay. Now ये Cook's distance क्यों important है? अब आप देखिए जादू. This is the statistical magic. Okay. So I click on the analyze. I click on the explore. So this is the command which I am going to show you. Analyze, descriptive, explore. Analyze, descriptive, explore. And I send Cook's distance here. I send Cook's distance here and click OK. After this, I have to check my Cook's distance. So this Cook's distance, this plot is known as box plot. इस प्लॉट को हम कहते हैं बॉक्स प्लॉट, और इस बॉक्स प्लॉट में ये जितने भी स्टार हैं ये सारे मेरे प्रॉब्लम्स हैं. ये क्लास के वो बच्चे हैं जो पढ़ते नहीं हैं और डिस्टरबेंस क्रिएट करते हैं. तो ये मुझे क्या करने चाहिए? निकाल देने चाहिए, है ना? सो आई हैव टू रिमूव ऑल दीज स्टार वैल्यूज बिकॉज एक्चुअली these are the outliers. And in statistics, the problem is that outliers are very problematic. All these stars are problematic for my study. So I have to remove all these Cook's values, all these stars, and because I have the sample size of 400. If I remove 10 to 15 observations, then I think there is not any problem. So how to remove it? I am going to show the process. Okay, let me repeat the process again. मैं आपको पूरा process एक बार फिर से समझा रहा हूँ. This is my regression model. Regression, linear. I clicked on the save button. I am saving the Cook's distance. Continue and okay. So after that, this is the Cook's distance. Then I go to analyze, descriptive, and I go to explore, and Cook's distance I save, send here, dependent list. और कुछ नहीं करना आपने, सिर्फ ओके कर देना है. तो ये मेरे आउटलायर आ गए और आप लोग मुझसे पूछ रहे हैं कि क्या मैं आउटलायर निकाल देने चाहिए. इंडस्ट्री तो निकाल देती है, आप निकालें ना निकालें आपकी मर्जी है. So in industry we always remove 5% outliers and rest is your intelligence whether you need to remove it or not. Okay, now I am going to show one thing more, how to remove these outliers. So just go to data and go to select cases. अच्छा, ये मैं क्यों कर रहा हूँ देखिए. If I remove those observations where my Cook's distance is more than 0.01, this is the cutoff value. My cutoff value is 0.01. आप देखिए ये मेरी cutoff value आपको दिख रही है. This is cutoff value is 0.01. So I am removing all the values of Cook's distance which are more than 0.01. So this I am going to do. So go to transform, data, select data. I want to select only those values if condition is satisfied. If condition satisfied, condition क्या है? My Cook's distance should be less than कितना? 0.01. I want to apply regression only on those observations where Cook's distance are less than equal to 0.01. Continue and okay. So what effect of this? You can see that some values you can see cut. Software ने क्या किया? कुछ values काट दी. So you can see there is a cut on some values. There is a cut on some values. ये जो cut हैं वो सारे मेरे कौन हैं? वे कौन हैं हमारे? ये outlier है, outlier. अब इसको remove कर देती है. So now we are applying the regression model on remaining observations. And you can see that the R square increases to 49. So 41 से 49 चला गया. So now my adjusted R square increases from 41 to 49, right? 41 to 49. So this is the magic of a regression model. You can, by removing the outlier, your R square, adjusted R square increases from 41 to 49, right? और आपने कितनी ऑब्जर्वेशन निकाली है? देखिए 381. I removed exactly 318 observations. I removed 18 observations out of 400, and my adjusted R square increases from 41 to 49. मैं अगर 5-6 और निकाल दूं, तो ये मेरा 50% से ऊपर चला जाएगा. So that's why we have to deal with this outlier very carefully in the regression model. Okay. So I hope you understand what I am doing here. So I explained you R square, adjusted R square, F statistic, P value. I am also explained you the T statistic, VIF, and standardized beta, unstandardized beta, right? Okay. Okay, तो अब आप मुझसे पूछ रहे हो कि एक बार मैं फिर से दिखा दूं. Okay, so no problem. I will repeat the outlier problem once again. No problem. Let me remove it. Okay. So first I save by clicking on the Cook's distance. after this step, you can see the Cook's value. Then I go to the analyze and explore Cook's distance. मैं एक काम और करने जा रहा हूँ, मैं थोड़े आउटलायर बढ़ाने वाला हूँ अपने. So my outlier is 0.01. 0.01. अब देखिए 0.01 से ऊपर ये मेरे आउटलायर हैं. So all the values which are more than 0.01 are my outlier. Okay. Now I am going to go for select cases, and if condition is applied, now I change the condition. 0.01 की जगह हम 0.09 कर देते हैं. So I am increasing the outlier to be removed. So now let's see. We are having new filter, and let's see the R square regression again after removing the outliers, and it is 0.495. 495. पहले हमारा 381 था, मैंने 2 और निकाल दिए. So I remove 2 more observations, and after removing the 2 observations, my adjusted R square increases from 0.41 से पहले हमारा हुआ, and now it is 0.41 से मेरा कितना हो गया? Let me check it. It is equal to 0.495. So now you can see that it is moving from 0.41 to 0.495. So this is called statistical intelligence, and काफी लोग कह रहे हैं कि ये डेटा मैनिपुलेशन है. तो उनके लिए मेरा एक सिंपल सा आंसर है कि ये डेटा मैनिपुलेशन नहीं है, ये एक इंटेलिजेंस है. तो अगर आपको पता है तो आप ज्यादा बेटर परफॉर्म कर पाते हैं, और अगर आपको नहीं पता तो आप इन सवालों में उलझे रहिए कि ये मैनिपुलेशन है, क्या करूं क्या नहीं करूं, और जिंदगी भर आप उसी मैनिपुलेशन में कंफ्यूजन में रहेंगे, और जो स्मार्ट लोग हैं वो अपना मैनिपुलेट करके पेपर पब्लिश करके आपसे आगे निकल जाएंगे. सो statistics is an art also. Okay, so now I explained you this portion also, and some few things I now want to explain. So let me show you this. Okay, and now I'm going to share one last concept on the regression model. So we are having the regression equation like this: alpha plus beta 1 into variable 1 plus beta 2 into variable 2, and so on. So if your regression model is free from multicollinearity problem and autocorrelation problem, etc. There are some other problems also which I can't cover in this session, but this is just like a trailer. Then the alpha, beta 1, beta 2 are known as blue estimators. So here B means best, L means linear, and U means unbiased, and E means estimators. And this theorem is known as Gauss-Markov theorem. So ultimately we have to prove that the regression model is free from all the problems, and if your regression model is free from autocorrelation problem, multi-collinearity problem, and other problems, then whatever the values of alpha and beta is coming, so the regression coefficients are known as blue estimators, where B means best. Best means the predictive accuracy will be highest. L means linear. Linear means the power of all the parameters should be 1. Unbiased means whatever be the sample size, if you increase your sample size or if you decrease your sample size, the regression coefficient will not change, and E are representing the alpha and beta, means estimators. So this theorem is known as Gauss-Markov theorem. So I try to explain the whole regression model in a capsule, and if you want to study in detail, so you have to read some good book, and this is the basic things which I explained you about the regression model. And so I hope this is the basic introduction of the literature regression model. And so whatever the time is allotted to me, I finished the chapter in that period, and now I am open to the query session.
Thank you, sir. Some questions are there, sir. I'll be taking one by one.
Yes, ma'am. Yeah, I know that because queries are more important. So let me answer all the queries.
So first question is from Miss Asha. She says, we usually do apply such statistics, but how to explain these in terms of research findings is the issue. How a non-statistics person can explain these?
Okay, मैडम ये जो नॉन स्टैटिस्टिक्स है ना, ये गांव के वो लोग हैं जो बड़ी बड़ी थ्योरी बनाते हैं लेकिन उनका कोई वजूद नहीं होता. अगर आपको स्टैटिस्टिकली कोई चीज कहनी है तो आपको स्टैटिस्टिकली प्रूफ करनी होगी, नहीं तो आप अपनी थ्योरी बनाते रहिए और लोग सुनेंगे, एक कान से सुनेंगे, दूसरे से निकाल देंगे.
Okay, sir.
जैसे मैं आपको बताता हूँ, हम लोग बड़ी सारी थ्योरी बना लेते हैं ना कि शेयर मार्केट बेकार होता है और धूप में बैठो विटामिन डी बढ़ेगा. ये सब चीजें ना तभी प्रूफ होती हैं जब आप स्टैटिस्टिकली प्रूफ करते हो. नॉन स्टैटिस्टिकल पर्सन की ना कोई सुनता नहीं है.
Yes, sir. Sir, Asin is she is asking for this role of standardized coefficient beta. Please explain this in.
Basically, because in most of the studies, especially in social science, we want not to predict. We want to see which variable is contributing more to the dependent variable, right? So, like for example, we always want to know that from where we are getting the happiness. ये जो happiness कहाँ से आ रही है ना? इस हिंदुस्तान में इसका आंसर आपको सारे बाबा दे रहे हैं. तो कि हैप्पीनेस कहाँ से आ रही है, लेकिन सिंपली रिग्रेशन लगा लो, स्टैंडर्डाइज्ड बीटा बता देगा आपको. स्टैंडर्डाइज्ड बीटा विल टेल यू which variable is giving you the happiness, highest happiness. So standardized beta is telling you the more impact from which variable is having the more impact, highest impact on the dependent variable. So when we want to compare the impact, standardized beta is simple answer.
Okay, sir. Thank you, sir. Dr. Manzoor Alam is asking, explain linearity and normality.
Okay. Linearity and normality. So two things you are asking. Linearity means basically there are two concepts of linearity. One is the linearity of the parameter and second is the linearity of the variables. So we in regression, the most important is the linearity in the parameter. Linearity in the parameter means the power of alpha and beta should be 1. You cannot use alpha square beta cube under square root of beta 3. You are not allowed to give the power of the beta. The beta must have one power, simply 1. So this is called linearity in the parameter. And second thing, which is called normality. Normality means the variables should be well-shaped. Means the distribution of the variable should be normally distributed, and it is not the assumption of regression. It is assumption of all the parametric tests. So if you want to apply any of the parametric tests, the first condition that you have to fulfill is your variable should be normally distributed. So normally distributed means bell-shaped curve.
Fine, sir. Thank you, sir. So next question is from Anubha Saini. She says, what if there is multicollinearity in our regression model? How can we remove it and any reference for this?
Ma'am, multicollinearity can be removed by factor analysis. There is no other solution mentioned by any book. All the books are saying that if you are using different variables, independent variables, and they are found to be highly correlated, the only solution of removing multicollinearity is to apply factor analysis on the data. So, and reference, regarding the reference, I think the best book of explaining the regression model is Damodar Gujarati. Damodar Gujarati Econometrics, Introduction to Econometrics is, I think, is the best book which you should read. Otherwise, in all the books, it is mentioned because multicollinearity is a very simple concept, popular concept, and very common concept. We can remove multicollinearity only by applying factor analysis. No other solution, because dropping the variable is not a solution. The only solution is that you club the highly correlated variables and form a factor.
Okay, sir. Thank you, sir. Sir, so many participants are asking, does the order of adding the new variables matter in getting the adjusted R-square value?
No, because ordering is not important. If a variable is important, that is important. If a variable is not important, that is not important.
Okay, sir.
So ordering in simple regression is not play a very important role.
Okay, sir.
Although
Dr.
there are
Preeti-
different,
Fine.
although there are different algorithms made by the softwares, like you can do stepwise regression, hierarchical regression, or there are different other regressions, backward regression, but they have some algorithm of entering the variables. But I don't think there is a problem in manual also.
Okay, sir. Thank you, sir. Sir, Dr. Preeti Birla is asking, we have understood the concept of outlier. How to explain the same in research while writing?
No need to write the because I have never seen the description of outliers in the research. So you just remove outlier for your sake, for your betterment of the model. Need not to explain it in the research paper.
Okay, sir. So next question is from Bratoti Roy. He says, what to do if collinearity still exists after cleaning the data as well?
Yeah, you have to go for factor analysis. Otherwise, there is no other solution. If independent variables are found to be highly correlated, then factor analysis is the only solution. There is no other solution of removing the factor analysis.
Okay, sir. Thank you, sir. So next question is from Payal Gupta. She says, what is semi-partial correlation?
ये partial correlation तो मुझे सुना है मैंने, semi partial correlation तो मैंने नहीं
I
सुना.
don't know, sir.
और
I don't know, sir.
हाँ, partial correlation का मतलब होता है कि actually when you control some of the variables and find out the correlation between two variables, so that is called partial correlation. Partial correlation is simply when you control some of the variables. Like in multi regression model, all the beta are known as partial beta. Partial beta means you are controlling the other variables. और ये सेमी पार्शियल तो आपने अपने दिमाग से खुद ही बनाया, ऐसा कुछ कंसेप्ट होता नहीं है.
Thank you, sir. The next question is from Any Mahajan. If the independent variable is ordinal and not scale, can we still use multiple regression?
Multiple regression you can even use when your independent variable is even categorical. So in case of independent variables, there is no problem. You can use ordinal, you can use categorical, but there are some rules of using all these variables. Yeah, the problem actually comes when your dependent variable is ordinal, or dependent variable is categorical, or dependent variable is right. So whatever I am explaining you is a simple multiple regression model when your dependent variable is scale variable. When your dependent variable is categorical or ordinal, then there is a problem. Otherwise, there is not a problem.
Thank you, sir. So next question is from Dr. Appala Naidu. He says, where we are using secondary data for time series analysis, how to check problem of multicollinearity and autocorrelation?
Actually, even if you are using the time series data, the rule of checking the multi-collinearity is still same, and even it's the same Durbin-Watson test you have to apply for testing the autocorrelation. There is no difference in the name of the test. Even if you apply use EViews or SETA or R for time series, you have to check the variance inflation factor as well as Durbin-Watson test for testing the collinearity and the autocorrelation.
Thank you, sir. So no more questions are there. Thank you. Now I would like to invite my friend Viljit for giving an official vote of thanks for this event. Thank you, sir. Your lecture was excellent. Thank you, sir. Hello,
Yeah.
Anu, thank you.
Viljit. Yeah, over to you.
Sure. Thank you. Thank you, Anu, for inviting me for official word of thanks. Honorable Dr. Ajay Kumar Chauhan, respected Principal Sir, FDP committee members, and all the participants. It's my privilege to have been asked to propose a vote of thanks on this occasion. I, on behalf of the ARSD College, University of Delhi, would like to extend a very hearty vote of thanks to the Honorable Speaker, Professor Chauhan, who enlightened us with his research knowledge, valuable tips, basic conceptual clarity between correlation, causality, regression, and step-by-step process on SPSS software. I must mention our deep sense of appreciation for Professor Chauhan for his work in the area of research. It was such a fruitful and knowledgeable discussion. I also wish to express my gratitude to our respected Principal Sir, who always been a guiding force and motivation behind all the successful events, Dr. Vinita Tuli, convener, Dr. Anjali Gupta, co-convener, and all the team members for their support and encouragement. I extend my heartfelt thanks to our valuable participants for their active participation in the event to make it successful. Thank you everyone for being a part of the FDP. Have a good day. Thank you so much, sir.
Okay. So one thing I want to say in the last, I have a Facebook group where I put all my resource material, because I am conducting these workshops regularly, and I put all my PPT, all my data set in that Facebook group. Kindly join and download from there.
Sure, sir.
Sure,
Thank
sir.
you,
Thank
sir.
you, sir. Thank you, sir.
Thank you.